Hello students, in this video I am taking sine bar as the topic. Sine bar is a instrument used to set the standard angles. So as we know, by Pythagoras theorem, the square of the hypotenuse is equal to sum of square of remaining two sides. And in trigonometry there are 6 functions. The first one is sine function. The sine function definition is sine is the ratio of opposite divided by hypotenuse. Sine is the ratio of opposite divided by hypotenuse. The sine bar is working on this ratio, that is sine ratio. Here you may observe in the diagram there is an angle theta, which is the angle set by the sine bar. Sine bar is used to set the standard angle. Then the angle set by the sine bar is alpha. To find the angle, how much angle is set by the sine bar, we can calculate by using a simple sine ratio formula. Sine ratio, sine alpha. Here the angle is indicated alpha. Sine alpha equals opposite divided by hypotenuse. Here opposite side is the height of the tile stock. You may observe here capital H, the height of the tile stock, and you may observe here the length of sine bar L. In this particular example, the length of sine bar is 127 mm. It may varies from 100 to 200 mm length of sine bar. The angle theta depends on height of the tile stock and length of sine bar. More the height, angle will be more. Less the height of tile stock, angle will be less. So this sine bar is basically works on sine function. The sine function is opposite by hypotenuse. In this diagram of sine bar, opposite is capital H and hypotenuse is capital L. Capital H is the height of tile stock and capital L is the length of sine bar. So you can observe here capital L is the length of sine bar and capital H is the height of sine bar. Using these two, we can find the angle set by the sine bar, that is alpha. So equation of sine bar to find the angle set, sine alpha equals h by L. Sine alpha equals h by L. It has no unit for sine alpha. So in this way, sine bar is used to set a standard angle. There are simple problems regarding sine bar. Sine bar is used to set standard angle. So we are generally asked to find the angle set by a sine bar. So if the sine bar is having only one tile stock, this is the formula. The tile stock means capital H, height of sine bar. Capital H is single one. Sometimes there are others tile stocks also placed near this drum on the ground. So here also there is sometimes there will be tile stock. That will be different case. I will discuss in the next topic also. If first we have to find the angle set by sine bar with single tile stock of height capital H and length of sine bar L. So let's take some examples. See, here it is exercise problem number 1. Here it is asked to find the angle set by a sine bar. So find the angle set by a sine bar of length 200 mm. Length of sine bar is 200 mm. Here is marked. Here in the question it is 200 mm. It is capital L. With a tile stock height of 100 mm. So 100 mm is the value of capital H and 200 mm is the value of L. So we know the equation of sine bar, that is sine alpha equals h by L. H is height of the tile stock 100 mm divided by L is length of sine bar 200 mm. Mm cancels, 200 20 and 100 20 cancels, remains 1 by 2. So sine alpha equals 1 by 2. By trigonometry ratio we know that alpha is equal to sine inverse of 1 by 2. If sine alpha equals 1 by 2, then alpha equals sine inverse sine to the power of minus 1 by 2. So sin inverse 1 by 2, by trigonometric table we observe that for the value of 1 by 2 the angles for sine function is 30 degree. So alpha is 30 degree. Alpha is the angle set by the sine bar. 30 degree is the angle set by the sine bar in this problem. So similarly we can find other also. In question number 2, problem number 2, find the angle set by a sine bar. Find the angle set by a sine bar having tailstock 10 mm, tailstock height 10 mm, and the tailstock is at a distance of 10 mm, at a distance of 10 mm from the drum on the ground. Here it is the drum on the ground. The drum on the ground is this one. This is the drum on the ground. It is ground is marked here. Drum on the ground. It is at a distance of 10 mm from the tailstock. It is at a distance of 10 mm from the tailstock. It is the distance. By observing the diagram, tailstock will become opposite side for angle set alpha. Alpha angle, the tailstock height becomes opposite side, and the distance from tailstock to lower drum on the ground is becomes adjacent side. So in this way we have to find the value of hypotenuse, that is length of sine bar. In the problem length of sine bar is not given. So by Pythagoras theorem, L means hypotenuse, it becomes L is equal to root of h square on the opposite side, and distance, that is adjacent square. So h square plus d, I am taking d means distance here, d means distance. So h square plus d square. So L is equal to root of 10 square plus 10 square. L is equal to root of 200. Root of 200 can be written as 100 into 2. Root of 100 is 10. You can take it taking out of square root, and only 2 remains under the square root. So sin alpha is equal to h by L. H value we know from the given diagram. H value is 10 mm, and L we have find it out, that is 10 root 2. So 10 divided by 10 root 2. 10 cancels 1 times, and the remaining is 1 by root 2. So alpha is equal to sin inverse 1 by root 2. But trigonometric table 1 by root 2 comes for the value of 45 degree in sine function. So alpha is equal to sin inverse of 1 by root 2, then alpha is equal to 45 degree. So in this problem the angle set by the sine bar is 45 degree. Similarly, as I explained in the beginning, there will be two tailstock, capital H and small h. This is the capital H and small h, two tailstocks are there. In this case, the formula will be the slide changed. Observe the problem number 3 here. Find the angle set by a sine bar of length 20 mm. The length of sine bar is given 20 mm, that is capital L. Capital L is the length of sine bar, 20 mm, with two tailstock, one is small one, h, small h, that is 5 mm. This is 5 mm. This is 5 mm, and with capital H 15 mm. This tailstock is 15 mm. The formula, there is a change in formula for sine bar with two tailstocks. So here you may observe, when there are two tailstocks, the equation of sine bar, sine alpha equals h minus capital H minus small h divided by L. So sine alpha equals capital H minus small h divided by capital L. From the diagram you may observe capital H is equal to 15 mm and small h is equal to 5 mm divided by the length of sine bar given in the problem is 20 mm. So 15 minus 5 divided by 20. 15 minus 5, it is 10. 10 divided by 20 equals 1 by 2. Sin alpha equals 1 by 2. So you can find alpha equals sin inverse 1 by 2. Sin inverse 1 by 2, by observing the table, for value of 1 by 2, the angle for sine function is 30 degree. the value of 1 by 2, the angle of sine function is 30 degree. So in this way we can find the value of angle set when there are two tile stalks. You should observe here, for two tile stalks, sin alpha equals capital H minus small h divided by L. So in this way we can simply calculate the simple problems on sine bar. So these are easy problems I have solved here. These are most frequently asked questions in the examinations. So by practicing, you may practice by giving different values for h, small h and L. You may practice yourself just using the simple formula sin alpha equals capital H minus small h divided by L. Similarly, with single tile stock also, you may give yourself some values like hypotenuse or length of sine bar. Here we have find out is 2 root 2. Similarly, you can find capital H with 10 mm. You may give 15 mm. Distance you may give 12 mm. Find the value of L using 10 mm and 12 mm of H and D. You may find the values of L, and you may next you can find the value of sin alpha also, and then alpha. So in this way you can practice different problems yourself. So thanks for watching. In the next video of this trigonometry, I am going to give you some simple observative calculations that are generally we can observe on natural days, like angle of depression, angle of elevation and so on. So that's also depends on the trigonometric functions and ratios. Anyway, Pythagoras is the base for everything. If we can calculate by using Pythagoras or by trigonometry functions. So thanks for watching. Thank you.